Hi everyone, and today we will be talking about matrix inverse. In the last lecture, we learned how to get the inverse of a matrix by using determinant and the minor method, and today we will be talking about another method, and namely that is Gauss-Jordan elimination. So I would like to start off with an example. Let's take a matrix 3 by 3, that is 1 1 1. Take 2 1 1 and take 1 1 2. So we ask what is the inverse. To do that, we will form something called an augmented matrix. That is, we will form a matrix like this. Now you can see that I am switching to third bracket, but it really doesn't matter. You can just continue with first brackets. So 1 1 1 2 1 1 1 1 2, and here I put a barricade and then I type the 3 by 3 identity matrix. And now you have to perform some row operations to get this inverse matrix. That is, our target is to make this block the identity matrix, and whatever will happen in this block will give us the inverse matrix. So let's proceed. So now we want to proceed. That is, we have our augmented matrix, and the first thing we want to do is that we take row 1, multiply 2 with it, and subtract it from row 2, and at the same time we will take this R3 minus R1, that is, we are subtracting R1 from R3. If we do that, we will have 1 1 1 0 minus 1 minus 1, and the other one is 0 0 1. And on this side, that is on the augmented side, we will have 1 0 0 minus 2 1 0 minus 1 0 1. And from here we will perform more row operations. That is, we want to do R1 plus R2, and then we want to do R2 plus R3. If we do that, that will give us 1 0 0 0 minus 1 0 and 0 0 1. And on the right hand side we will have minus 1 1 0 minus 3 1 1 and minus 1 0 1. And at this point you can divide row 2 with minus 1. If we do that, this will become plus 1, and this will become plus 3, this will become minus 1, this will become minus 1. So at the same time you can write like, for this, R2 by minus 1. So we have the identity matrix over here, and this will be our inverse matrix. This is how you can find out inverse matrices. Now let me explain a bit why these row operations were necessary. The idea is to get this identity matrix over here, right? To do that, what we can do, and what we have done here, is that we take these rows and we are trying to make some pivots. These pivots, that is, if this is a pivot, then all the elements below this will be 0. Similarly, for the pivot over here, all the elements above and below will be 0. Similarly, for this pivot, all the elements above this will go to 0. And this is what we have here precisely. And this is how one can easily determine the inverse of a matrix, and you can always check by using a inverse one whether that gives you the identity or not. So this will be it for today. I hope you enjoyed it, and I'll see you guys on the next lecture. Thank you.